Well, this lecture gives a brief introduction to Bayesian statistics. At the very beginning, I want to provide an overview of several major statistical cultures / paradigms. First is what a lot of people know as frequentist statistics. Under this paradigm, statistical patterns can be found through probabilistic frequency. That is a long outcome of a long-run series of experiments or relative frequency. This paradigm is a more recent development by R.A. Fisher, Jerzy Newman, and Egon Pearson, son of famous Carl Pearson. The second paradigm is likelihood theory, which lies in this great area somewhere in between frequentist statistics and Bayesian statistics, which is the focus of my lecture. So according to likelihood theory, well, there's this joint probability function used to describe data with all the sufficient or new information. And maximal likelihood estimation is a typical application of this paradigm. And third one is Bayesian statistics, which is going to be the focus of my talk in the slides that follow. The fourth paradigm or culture is what is called machine and statistical learning. And sometimes people will label that as part of AI field or artificial intelligence. The author of the seminal work, Classification and Regression Trees, published in 1984, Brahman, right? Wrote a paper titled The Two Cultures in Statistics, roughly, the title of that paper in 2001 and published in Statistical Science. In that paper, Brahman argues that while Bayesian statistics can be lumped under frequentist statistics or along with frequentist statistics, and what really stands out as two major competing, or sometimes people say complementary, statistical camps. And relatedly, probably philosophical camps about finding patterns of our world and data. One is called data modeling culture, okay? And this culture assumes a stochastic data model to begin with. And second culture, a competing culture, is what is called, what Brahman calls algorithmic modeling culture, which is to find a function or algorithm that operates on X, that is an array of predictors or independent variables, and the response variable Y, okay, the predictive. So what is Bayesian statistics? Well, it is an important and fast-growing statistical paradigm or culture or philosophy. And it uses a very different statistical and philosophical view. And some scholars have tried to advance this view to become a philosophical view. So they call that Bayesian epistemology, okay? And according to Bayesian epistemology or Bayesian statistics or Bayesian inference, probability is not objective. It is a degree of belief, okay? And people have prior belief, right? About some outcome and events, okay? Then we can update that prior belief with data if available. And these two are going to coalesce to produce what is called posterior belief. And later on, we will talk about prior probability, that is prior belief about the distribution of parameters. Then we have likelihood function, right? That is, data, right? Washed, updated, processed with data. Then we have posterior probability distribution, that is posterior belief. Well, why the scientific field waited till 1980s and 90s to begin use Bayesian statistics is because there's not lacking of criticism of this paradigm. Okay, and here I'm just going to quickly talk about several of a long list of criticisms of Bayesian statistics. First is considered to be automatic inference engine, right? We have prior probability, then processed by likelihood function, then we get posterior probability. But that's very automatic, okay? And it is subjective. It is subjective. Some scholars argue that because of assignment of prior probability sometimes is a little bit, to them appears to be arbitrary and subjective. And for the critics of Bayesian statistics, they call Bayesian approach statistical heresy. That is, it's like postmodern view about statistics. And it was not until the late 1980s and early 1990s when MCMC, that is Markov-Chern-Monte-Carlo, became available that the Bayesian paradigm turned into a serious challenger of then traditional frequentist paradigm. And for traditional frequentist paradigm, I mean all the things that we have been doing with statistics, right? The non-hypothesis statistical significance testing, and all the traditional practice in statistics that we have been doing. Okay, they are called. They can be lumped under frequentist paradigm.